Morning, everyone. Am I audible to you guys? Okay. So yesterday we discussed two things, two encryption method. One is IDEA, International Data Encryption Method, and other is the Blowfish. So today we will see advanced encryption standard, which is like modified version of DES or more widely used one. Okay, let me just share my slides. Okay, so what is advanced encryption system? It is like most widely adopted and it supports both hardware and software. And it is more like more stronger and faster than DES approach. So if you remember DES, how many keys were there? For DES, we had 64-bit plain text and 56-bit keys. But in case of AES, which is also a symmetric key, symmetric block cipher, and it uses 128-bit keys. So there can be different numbers of keys. One is 128-bit, other is 192-bit, and other is 256-bit. So using that secret key and plain text, it just generate your ciphertext. That means depending on the block size, so ciphertext can also be 128-bit, 192-bit, and 256-bit. Okay. So in case of DES, block size was 64, means plain text, and for AES, again it's 128. So if I say DES versus AES, so if I say DES and AES, AES is advanced and DES is just data encryption standard. So in case of DES, your block size is 64 and in AES it's 128. And key length is 56 for DES and for AES it can vary from 128, 192 to 56. Okay, then number of rounds. Okay, so in case of DES number of rounds was 16 and in case of AES it can be 9, 11 and 13. So in DES mostly we saw substitution and permutation, which is also known as confusion and diffusion. तो आहेच. Okay. So in case of DES, we saw two types of things. Means your encryption primitives were were mainly based on your substitution and permutation. Remember, we had S boxes and also permutation tables. And in case of AES, we have substitution, shifting, and bit mixing. Okay, substitution remains same. Then we have shift, and then we have bit mixing. So, and the cryptographic primitives is mainly confusion and diffusion for DES. Confusion is nothing but your substitution and diffusion is nothing but your permutation. And in case of AES also it's same, it's confusion and diffusion based method and it's open for all. The main advantage of AES is that AES is open for all to use. Okay, and selection process it is like publicly open to everyone. Okay, so this is all about AES and it is very practical one and there is no attack cryptanalytic attacks available for AES till now. So in future if you want to do research maybe you can do this too. Maybe you want to find some attack through which you can just break AES encryption. Okay, so now let's see what are the operations for uh, operations of AES. So this is not exactly a Feistel cipher like DES. Here we have different other methods. We have it's more like iterative. Okay, iterative means maybe same permutation substitution network just keeps going on differently. Okay, in Feistel cipher we saw we uses P boxes and S boxes, then we always XOR them, then we do swapping and all. So that's your basic characteristics of Feistel cipher. But here in case of AES it's more iterative, so it is mainly based on your substitution permutation network and there are different link operation and some of which involve like replacing inputs by specific inputs like your substitution tables. Of course these substitution tables are already fixed substitutions and this is a bit similar to your DES. So and other involves like shuffling of beats and shuffling of beats is nothing but your permutation. So all the operations in AES are did with the help of bytes. Okay. In case of DES, we consider the bits, but here we mainly consider the bytes. So AES will treat 128 bits of a plain text block as 16 bytes. Okay, and these 16 bytes will be arranged in a matrix format. Okay, it can be a tabular or row format. For example, I can show you, it's just example, okay, how we can represent it. So you can just write uh, suppose buy me pencil. Okay, so in case of AES we can represent the block. Of course this all these words will be generated into binary, but just for the learning purpose just remember we represent a 128 bit thing into 16 bytes and it will be a 4 by 4 matrix. Okay, we have to generate 4 by 4 matrix. So if I say just 1 2 3 4 1 2 3 4, how you can write it? You can just write I, this is a gap, me, this is a gap again, pencil, pencil. and this will remain like this. Okay, so this is just example how we represent in a matrix format 4 by 4. Okay, so next, the number of rounds in AES is variable and depends on the length of the key. Okay, in case of DES, we saw some fixed rounds, but here in case of AES, the rounds will be depending on length of the keys because we can use different keys. So 10 rounds will be for 128-bit keys, there will be 12 rounds for 192-bit keys, and there will be 14 rounds for 256-bit keys, and each of these rounds uses just different 128-bit round keys, and which we can just calculate from the original AES key. So the process looks like this. So a more simpler, see, the round will mainly depend on number of keys, round 10 for 128, round 12 for this, so it will depend on your choice. Okay, so whole encryption process, you can say we will just provide plain text, then there are certain functions. So first we will do add round key, then there will be four main processes. One is sub bytes, then one is shift rows, mix columns, and add rounds. So what happens in byte substitution or sub bytes? The 16 input bytes are substituted by looking up a fixed table. So there will be a S box table. So based on that designed S box, those are already fixed. We are just going to substitute this 16 bytes. Okay, then the result is will be in a matrix format because the plain text we have already converted into a matrix format. So after substitution also we will get just a matrix format 4 by 4 rows and columns. So next is your shift rows. So what happens in shift rows? Each of the four rows of the matrix is shifted to the left. So any entries that like fall off, then we can just reinsert on the right side of the row, and this shift will just carry forward with different things. So there are different conditions. Okay, so byte substitution, I'll just show this process. So this same process will continue like 16 rounds, 10 rounds and all depending on the number of keys. Okay, so this is the same process I have just written, add round key substitution and all. So this one I have already mentioned, 16 input byte will be substituted with the help of S boxes. Then for the shift row, what happens first, we the first row is not shifted. Okay, then second row is shifted one byte position to the left. So then third row is shifted to the two position of the left, and fourth row is shifted three position to the left. Then result will be a new matrix. Okay, so just for example, okay, suppose 1 2 3 4 1 0 1. So if this is the thing, so what we have to do first is first row is not shifted, so this one remains same. Then second row is shifted one byte position to the left. That means this second row will be shifted one byte. So final outcome will be this one will come here. So 0 will be shifted here, 1 1. Okay. So next, your third row is shifted to two position left, that this 2 will come this here. You have to shift it. Then again fourth row is shifted three position. That means this will again shifted to here. So for this one it will be this 0 1 1 0. Okay, so in this way you have to perform the shift row operation. This is just an example. Okay. Okay, so your next is mixed column. What happens in mixed column? Each column of 4 bytes is now transformed using a spatial mathematics function. This mathematical function we have also seen in case of Blowfish or your triple DES and all. So this function takes as input the 4 bytes of one column and outputs 4 completely new bytes, so which will just replace the original column. The result will be another new matrix consisting of 16 new bytes. Next method is just add round. What it will do, it will just uh, last round. It just last round. So 16 byte of the matrix are now considered at 128 bits. So after performing all those rounds, again 16 bytes will be considered as 128 bit, and that 128 bit will be absorbed with the 128 bit of the round key, and this will be the main result of your 16 byte cipher. So what will be the decryption process? Decryption process is just the reverse one. So whatever we did first in case of encryption, we started from byte substitutions, shift through and mixed column dead and round key. So in case of decryption, it will be total opposite, reverse order. So we will do add round key first, then mixed column, then shift row, and then byte substitution. Okay, so DES for AES, this is all about AES. So it's just like DES, it is AES is more secure, but similar to DES, the security will be assured only if it is correctly implemented and good key management is employed. Because right there are so many keys are involved, so obviously we will need a good key management system, and of course we have to make sure it has been implemented correctly because it's a complicated process. So I will not show any example because it's going to take long time. You can see this 128 bit, it will take a long time. So just know the process, what happens for AES. Mainly just remember how many block cipher is used, how many keys are used, what's the difference between DES and AES, and what are the main process. Means even if you just remember these 4 steps, then also fine, because these 4 steps is for one round. So if there are 10 rounds, then for the 10 rounds this process will continue. Okay, and in the last round it's just one step, one, just for one step, and this round will just continue for 10, 12, and so on depending on the key size. Okay, so that's all about AES. So just take 5 minute break. I'll start a different topic. Okay, so the next topic is confidentiality using conventional encryption. So, do you guys remember what is confidential? Okay, anyone? What is confidentiality? It was from our first class. It's very simple. What's the main purpose of encryption? Safety, to make sure our info is unaltered. Yes, both are correct. So confidentiality means whenever we want to keep something secret and want to keep it secure, then we make sure that our information is confidential. If we want to keep some secret, we say it's confidential, right? So let's see how it can be done. Okay, so there can be different attacks in our whole networking system. Okay, there are some confidentiality attacks, and the potential location for any confidential attacks can be in our LAN connections or in multiple connections. A very typical scenario is like workstations on LAN access, then other workstation and server on LAN. So anyone can just eavesdrop and monitor and capture the traffic on the LAN, and attack can take place at any of the communication links. So we have already discussed what is passive and active attack, right? So active attacks, they will just try to gain a physical control over our whole transmission process, and passive attack, they will just observe all the transmission. So for that, to keep the confidentiality in our traffic, there are two main things. Okay, so if encryption is to be used to counter this active or passive attack on confidentiality, we need to decide what to encrypt and where the encryption function should be located. So two general placement of encryption is the linked and end-to-end encryption. So what is linked and encryption? What is linked encryption? Anyone has idea? It just link to link encryption. That means we provide an encryption machine or system between the ends of two devices, and all traffic on the communication link will keep secure, and the message is vulnerable at the switch. What the disadvantage of link encryption? In case of link encryption, we just provide the security only in the signal, means data packet is still we need to decipher at the switch. So at switch, it will be still vulnerable to the threats. And what is end-to-end encryption? It just carried out in two-end system. So the source host or the terminal encrypts the data. The data in encrypted form are then transmitted unaltered across the network for a destination host. So here from this picture you can see what is your end-to-end encryption. If this is a whole thing, this is your server, these are your two computers, the end-to-end encryption device, we will just keep at this ends. Okay, and linked encryption devices will be uh, incorporated on every link. There will be a link from server to these switches, then again these switches, then hubs, routers, everything are interconnected, right? So for every link, there will be a link encryption device. So that's the main difference between link encryption and end-to-end encryption. End-to-end encryption just between server and all the other devices. So what's the main motive? See, in case of link encryption, we just secure the whole packet, means whole data information packet, everything is encrypted. Okay, then those are carried forward to the other machine or destination machine unaltered. Nothing gets changed. Okay, but in case of link to link encryption, since it's like link between any types of switch device and all, every time we send something, we need to decrypt it. Okay, suppose there is some information sent from server to this packet switching network. So when I send it, there will be encrypted. So the moment it will reach this particular hole, switch, it will decrypt it. Again, when it will send it to other one, then again it will encrypt it. Then the next switch will again decrypt it. So you can see when we send the data, so at this point it's secure. But the moment it reach the switch, it's again insecure because to get the message, it will always decrypt it. But in case of end to end, it's not like that. Everything will be sent unaltered. So one problem is that, yeah, I'll come to this one later. So in link encryption encrypts all the data along a specific communication path, and not only is the user information is encrypted, but the header, trailers, address, and routing data that are part of packets are also encrypted. And in case of end-to-end encryption, the headers, address, routing, and trailer information are not encrypted. Okay, so it will just enable attacker to learn more about a captured packet and where it is headed. And link encryption is mostly for the lower layer of OSI model, that will be your physical and data link layer. And end-to-end encryption is mostly for network layer. So in case of link, again, all the information is encrypted and the packets must be decrypted at each hop. So the router or other intermediate device knows where to send the packet next. But in case of end-to-end, the packets do not need to decrypt and then encrypt it again at each hop because header and trailers are not encrypted. So can you tell me, in one point, suppose in end-to-end encryption, the headers are not encrypted, but data is encrypted. And in case of link encryption, uh, everything is encrypted. Can you tell me a bit disadvantages of both, or if there are any other alternatives you can suggest? Means you know the disadvantage of both, right? So can you just tell me one alternative what we can do? So isn't it better that we combine both? Because for one case packets are not uh, encrypted. Hey, Koila, hey, Koila. one packet is header is not encrypted, and for other one, every time we get to the switch it need to decrypt it. So one possible scenario is it's already implemented. It's just combination of both link and end-to-end encryption. That will be obviously more secure whenever we send the data from one host to one. So in case of end-to-end encryption, the header will be open, right? So that will be a threat when it reach to the switch. But again, in link encryption, uh, the header will be uh, encrypted too. So it will reach the switch and it will decrypt the header. Then only it will know the address for the next next hop. Sorry, wait. Okay, sorry. So yeah, the best way is to combine both. So instead of just going for one type of encryption, we can just implement both at the same time. Then it will be more secure. So this is again the same thing actually, the characteristics of link and all. Here it is shown security within the end system and the intermediate system. For the link, message exposed in sending host and message exposed in intermediate nodes. For the end-to-end, message encrypted in sending host and encrypted. These things you can just learn by your own. I can just share the slides. These are just theoretical. This part also I have already explained actually. So what can be the logical placement of your end-to-end encryption function? So we can just already mention anyway the placement of link encryption at the lower level, which can be your physical or data link layer. Then for end-to-end encryption, several choices are possible for the logical placement of your encryption function. And for end to end we can just put it in network. Yeah, initially I mentioned it's network, but it's also possible in transport layer as well. So yeah, this is same thing actually. And at the application layer too, yeah. So th- just one more additional point for the end-to-end encryption, we can just also put it in application layer. So internetworking between different architecture is available, and we just need to find the number of entities. But the thing is, if there will be more users, it will just increase a bit, a lot. So it might be a bit difficult to implement it there. So this is just the scope of implications for all these encryption methods. This way, you guys already know actually. I hope you guys already know about OSI model and TCP/IP model. Here, just showing where we can just place the link level encryption and where we can just keep end-to-end encryption. This is again almost same how we can just encrypt the communication. So if this is the application level encryption on links and at routers and gateway. So this gray portion is your encrypted portion. This is your encrypted. and here this part is encrypted, and here this part is encrypted. So you can see in this case in gateways and this it's not exactly encrypted. This is a link level encryption. Traffic confidentially. Okay, I guess this part I'll just start in next class. Okay, there are just two things. One is traffic confidentiality. You guys already aware of traffic confidentiality you guys already know. So the just that different types of information can be derived from your traffic analysis. One can be the identities of the partners, then how frequently the two partners are communicating, what could be the possible message pattern, message length, quantity of message, and there can be different events. So to handle this traffic confidentiality or eavesdropping, so we have again different approaches. Again, it's similar type of approaches like link encryption approach and end-to-end encryption approach. So there will be some keys and all. So those things I'll discuss later. So that's all for today. I'll just stop sharing. I hope this part is clear. This is not that tough. Just two main things for the confidentiality. One is end-to-end, one is link. Just remember where we keep end-to-end and link one. Okay? Okay, thank you.
Ma'am, Dasudhar is unwell, so she is absent.
Sorry?
And Dasudhar is she's not well.
Oh, okay, okay. I'll give her attendance, no problem. So
Okay, ma'am.
I hope this part is clear to everyone.
Yes, ma'am.
Yeah. Okay, thank you.
Thank you, ma'am.
Okay.